All right, reflection, symbol, little review, symbol, lowercase r. And I said it's lowercase r for a reason because uppercase R is reserved for another transformation, and that is today. Uppercase R is for rotation. Along with that uppercase R, you're going to get a degree measure. So for now, we'll put in 90. That'll be the amount you're going to rotate it. 90 degrees. Now, there's an issue that comes up. Which way? Right? I could go this direction, which we are hopefully known as clockwise, or we could go in this direction counterclockwise. How do we know which way we're rotating if the problem doesn't state? It all depends if the degree measure is positive or negative. If it's positive, like it is in my example, if it's positive, we rotate counterclockwise. And I'm going to abbreviate that CCW so I don't have to write it out all the time. We rotate counterclockwise, in this case, 90 degrees. Well, what would happen if I want you to go clockwise? Now I would change 90 to negative 90. Now we're rotating in a clockwise direction. So it all depends if it's positive or negative, which direction. Now I'm being dead serious here because I worry with rotations. I think these are the hardest ones we're going to do. Do we know the difference between going clockwise versus counterclockwise? In all seriousness. And you'll see why I asked that in a second. So positive, we're going counterclockwise. Negative, we're going clockwise. All good? All right, let's actually do a rotation right now. So I got triangle DEF. So you guys can go ahead and graph that. And then how the heck are we going to turn it? Okay, let's see if we actually do know this counterclockwise versus clockwise business. I just came out and said do it counterclockwise. All right, I could have left it positive 90, but I came out and said go counterclockwise. You guys know your quadrants? 1, 2, 3, 4. I'll actually write that on there. All right, let me see if you really know this counterclockwise, clockwise business. Point E, where quadrant will end up after I do this rotation? Counterclockwise, so 3. Where's F and D going to end up? 2. Everyone good? Counter versus clockwise. All right, how do I actually move it though? Only one where we're physically going to rotate it ourselves. Counterclockwise, should I be moving my paper to the left or to the right? Left. 1/4 turn to the left, everyone. Go ahead. 1/4 turn to the left. You're rotating your triangle right now. Leave it there. Ready? Tell me what's the new point D now? As you look at it, what's the new point D? -3. Oh boy. 2. So that's going to be D prime. I'm just going to jot these down and then I'll go back to the original graph and graph them. So -3, 2 is D prime. Where's E now? -6, -1. So there's E prime. And where's F? -6, +2. Now I go back to my original graph and I graph these new points. All right, and I graph these new points. And there it is, rotated 90 degrees counterclockwise. All right, is 90 the only thing I'm going to ask you to rotate? Absolutely not. Here you go. 90. I do one more quarter turn. That's how many degrees from the beginning? 180, one more quarter turn, 270. So multiples of 90 for today anyway. 90, 180, 270, or any negative version. All right. Questions here? Yep, anything. Turning it. Okay, I get it. Maybe you don't like this whole rotating your paper. You get confused. I don't know if I'm going to turn it in the right direction or not. Well, for you guys, I have the actual rules if you want to memorize them or not. This is your call. You can keep turning the paper like I just showed you, or you can memorize the rule depending on the degree measure. So for 90, as you guys can see, your coordinate flips. You flip the coordinate, but you change the sign on the first one. That's for 90. 180, change the signs. I'm just blowing this up for you on your paper. And if you want to remember the rule for 270, flip them, but now change the sign on the second coordinate. I don't know, whatever you prefer. Okay? Turn the darn paper or know the rules. Okay? Well, wait. You said we could also go in the negative direction. What are those rules? What if I wanted to go negative 90? That's the same as what? 270 in the positive direction. If I wanted to go negative 270, that's the same as 90. Here's a tricky one. What if I wanted to go negative 180? You're in the same spot. Good job. All right, same spot. All good. All right, time to have a little fun here. We just don't always have to rotate on a graph. So here's what I need from you. I need your help. I have this line L that's going to stay right where it is, and I have this little piece of a triangle here. And what I want to do is start rotating this triangle around L. So I have L, the triangle's coming off, and I just want to start whipping this sucker around. All right? Eventually, what type of solid is going to be formed as I whip around the triangle around the line? I keep going and going and going and going and going and going. Oh boy. I keep going around and around. What's going to end up forming? Oh boy. All right. Obviously, I need a little visual here. Okay. I didn't get rid of it, did I? Nope. Everyone see that, what I'm describing here? Going around and around, we end up with a cone. Yes, we end up with a cone here. Okay, we end up with a cone. Whew, I'm nervous to ask about this next one now. I have that square, rectangle, not too sure, but I'm going to rotate it around line L, line L, line L. It'll end up being will it end up being a cylinder? A little visual. Anybody ever been through revolving doors? I have. You're going through this example right now. Because you have a little rectangle, which is your window, and you go through and around, right? Through a fixed pole, probably. You go around, and it ends up being, yes, a cylinder. Now, the next one, I don't have a visual for you, so hopefully these first two did the trick. I get that circle around and around and around. A sphere, yes. Okay. I used to give that one. I didn't like it because it was a pretty detailed, hollowed out cone. Okay. All right. Questions there? Because what's going to happen, and I show you this because I've seen questions on the Regents exam. Well, they'll put 3 inches here, and I don't know, 5 inches here, and they'll say after rotation around line L, and they give 4 choices. What's left after you do that? Well, we just figured out it was a cone, right? What do you know about the diameter? 6. It's not going to be 3. It's going to be 6. And then this is the height of the cone, 5. Yeah. Now, very similar to my one I just showed you there. Okay. All right, all good. Because now I'm going to see what you're made of. Reflection, translation, rotation, all in one problem now. Let's go. A lot of digging deep here. A lot of digging deep. Here we go. Ah, shoot. I got to delete that. Go ahead and graph triangle ABC. First thing I need you to do, reflect ABC over the x-axis, and I'll ask somebody what the new coordinates are. X-axis, not the y, x-axis. All right. On you guys now. What are the coordinates of prime, A, B, and C? Here we go. 23. Anybody 23s in the house? Sevens. Here we go. A prime. B prime. And C prime. All right, everyone, all good. If you went ahead, hey, I hope you're reading. Hope we're reading if you went ahead. Part B, I'm going to do a translation, but which coordinates do I do the translation on? The primes or the original? Primes. You never know. You never know. Read it carefully. So yes, we are going to do a translation on A prime, B prime, C prime. Where are all your X coordinates going? Left. How many units? 6, and all your Y coordinates are going down 2. Here we go. And tell me state the coordinates as well, in addition to your graph. The new coordinates when you're ready. 14. All right, we're good to go. No issues so far, of course. Reflection, translation, no big deal. But now here comes some tougher stuff. Take the double prime coordinates and rotate them 90 degrees clockwise. Now you're going to show me if you know what clock or counterclockwise means here. So again, my recommendation, turn the paper, write the coordinates down, turn it back, graph them. Okay? Clockwise, clockwise. This should be interesting here, clockwise, like a clock. So do you turn your paper right? Do you turn it left? Clockwise. Look at your graph too. Is A double prime moving clockwise? Is B double prime moving in a clockwise direction? Remember, if your point's in quadrant 3 and it's going clockwise, it should go to 2. If it's in 4, it should go to 3 clockwise. Gonna need a stud for this. Gonna need a stud. Let's see if the generator heard me or not. 11?
Yeah.
Okay, let's find out. Let's find out.
Okay, so a triple prime is -3, 4.
Well, we're onto the right track, so I have faith you turn your paper the correct way.
I actually did a little conversion right
Oh, okay, that's fine too.
All right, B triple prime is -6, 0.
Yep,
And C triple prime is -3, -2.
got it. All right, and there's the triangle right here. Any issues? And then finally, let's go back to reflections. Anybody want to tell me anything here? Yeah. Hopefully you're not going back to your triple prime ones. Why? The quadruple prime is the image of ABC, the original 3. And you're going to reflect them over y equals -2, which is what type of line? Horizontal line going through -2. Y equals -2, the original coordinates. The original coordinates are getting reflected over y equals -2. Good story. Let's do it right now. Every little detail matters, as you're starting to see. And there might be also one other trap you may fall in.
That's not a good attitude to have.
Looks like we'll need another stud here. $18. -2.
Oh wait, no. Oh yeah. No, never mind. +2. I'm done. +2 and -5.
Okay, real quick. Hold on. It's correct. If anybody had 2 -3, that's because you're counting from the line of reflection instead of counting from the origin. Rookie mistake. All right. Count from the origin, not the line of reflection. Keep going. All good. I'm giving you plenty of time to start this and your 2 Regents questions. Graph means graph. It's not optional.